Hello students and families, Miss Slyman here, and so this is the start of 8.5 notes on compound angles or sum and difference formula. And so I'm going to start with this example of how we can use our special right triangles to calculate values that we don't know exactly. And I made a copy down here because it takes a fair bit of space, and so I'm going to show you how it can be done, but then we're going to look at the formulas that make it so much easier. So cosine of 105, well, let's think about 105 degrees. 105, there's 90, and then from 90 we're going to go another 15. So that's up here. But really, if I think about that, so that's 105, 105, which means that inside that triangle, the reference angle is 75. Okay, so now let's think about a 75-degree angle over in quadrant 2. Well, I'm going to try and draw this so that it works. So 75 degrees is like a 30-degree angle, and then a 45-degree angle on top of that. So I'm going to make a right angle to connect this here, and now we can see that I've done a terrible job because if it's 45, those should be the same length. So let's try and make it a bit better. All right, so 30 degrees, something like this. All right, that length, I'm going to go up. So 45 degrees here. So of course we'd have 60 here. If I continue and make a rectangle around all this, so let's continue this up to make a rectangle. All right, so what I'm looking for is the cosine value. So remember, cosine is going to be adjacent over hypotenuse. And so really what I'm looking at is this triangle here. And gosh, do I wish this Notability let me draw straight lines. So I'm looking in this triangle here, and cosine is going to be this adjacent over this hypotenuse here. All right, well, in this triangle, we've got 30, and then we've got 60. We drew a right angle here. Okay, so there's a right angle. So 60 here means that this is going to be another 30-degree triangle up here. All right, I've got my 45, 45. So if we think just about this in our unit circle, well, if we're looking at this side now of the 75, that's here. But if we look at our full 30-degree triangle, so it's like I've extended out to here to get my 30-degree triangle. And we know if we've got it in our unit circle, then cosine of 30, this bottom side here, that long side, is going to be root 3 over 2. And we know this short side here is going to be a half, and that's assuming a unit circle, so this full hypotenuse here is 1. Well, if this is 45, 45, this is also going to be 1. So now I can look at this triangle. So I'm going to draw it again. And I'm looking now at this triangle, so I'm going to make my lines, and we have a blue long side here is 1. And then looking at my angles, if we put our 30 here, so we know we want to get this side because we want to somehow actually, it's not this side we want this side. We want the side opposite because I want to figure out this length. And I know the whole thing is root 3 over 2, so if I can subtract this, then I would know my x. So my x is the same as this up here. So I want to know this side. Let's call that one y. Okay, so that's across from my 30. So I'm thinking of sine. So I know that sine of 30 is 1/2, and from this picture, sine of 30 is y over 1, so of course that makes y equal to 1/2. That means that my x value, so x is going to be root 3 over 2 minus 1/2. That's this bit. Now I need my hypotenuse. Well, my hypotenuse is inside of my 45, 45, 90 triangle. And this is 1 and this is 1. So we know that sine of 45, and here's our h that we're looking for. Sine of 45 is root 2 over 2. And according to this picture, it's 1 over h. So that means my hypotenuse then is 2 over root 2. All right, so that means that I can figure out now cosine of my angle here. Remember though that this x value is negative because I'm in quadrant 3. So let's do my cosine of 105 exactly. That's going to be adjacent over hypotenuse, so negative of that length, so root 3 over 2 minus 1/2 over my hypotenuse, 2 over root 2. I'm going to simplify, that's negative root 3 over 2 minus 1/2 times root 2 over 2. That's going to give me negative root 3 root 2 over 2 times 2 is 4. I'm going to leave it as 2 times 2 though, you'll see why in a second, plus 1/2 times root 2 over 2. All right, so notice, and I'm going to rearrange this actually, 1/2 root 2 over 2 minus root 3 over 2 times 1 times root 2 over 2. All right, so notice our original angles. We said that cosine of 105, we were then looking at the equivalent, so we were saying that that was the same as negative cosine of 75. And remember, cosine of 75 degrees would be quadrant 1. So I was using my reference angle, but I have to make it negative because it's quadrant 2. So that was the same as the negative of cosine of 45 plus 30. And look at these values. All of these are ratios of 45s and 30s. So I can come out, calculate this exactly. It's going to be root 2 minus root 6 all over 4. But let's come and look at the formula. So the formula says that if I have cosine of a plus b, so here's a sum formula. So I had cosine of, let's scroll down a little bit. So cosine, if we just look at cosine of 75, if we look at the quadrant 1 value, that's cosine of 45 plus 30. So this formula says that we've got, let me just take a little picture. Paste it in. All right, so this formula says that it's going to be equal to cosine A times cosine B, so cosine 45 times cosine 30, cosine of 45, this is 105, so we've got our negative version. But remember up here, we had our negative outside of all of it. So if we had stuck with our original, then we would have had the parentheses here. So we're looking at 75 instead of 105, which we're making negative. All right. So minus, notice it's plus minus, so I have plus up here, but minus plus over here. So now I have to go minus sine of 45 times sine of 30. Let's pretend that I wrote what I said. All right, so that's root 2 over 2 times root 3 over 2 minus root 2 over 2 times 1/2. We wanted cosine of 105. Cosine of 105 is negative of the cosine of 75. So that means it's the negative of this, making this part positive, and this part negative, which is exactly what we got over here. So it is possible to draw sum and differences to make a bunch of triangles and rectangles, but boy, is it a hassle. And instead, we can use these compound angle formulas. So all of these can be proven, and if you want to see the proofs, I have some nice ones that don't use any angles. They don't use actual angles, they just use variables the whole time to prove them, but you're never going to be asked to prove them even in higher level. You're just going to be asked to use them. So that's what the next examples are going to do. I'm going to write up the solutions, or I'm going to write down the solutions for these. I have them drawn by hand, and I'll leave them hanging on the board if you want to see them, but feel free to try and draw these yourself. The 7 pi over 12, there's a hint there that 7 pi over 12 is the same as sine of pi over 4 plus pi over 3. And 19 pi over 12, well, that's of course pi. So I'm going to take away a pi, and then I'm going to have a 7 pi over 12 left. So very similar over here, because 7 pi over 12 is these guys. All right, so try those out, but come back and we're going to look at using our formula to solve problems like this.